So pin core testing basically determines that that the like pins are, have the correct type of structure. There's no opens, no shorts, and the supply, consumes the right amount of current. First thing you do is take your emitter and you tie it to the ground pin of your device. So on this device, it happens to be pin 6. So I'm going to grab this and go 1, 2, 3, 4, 5, 6. And the first thing you want to check is to make sure you have a proper supply, structure, and it, the current rating is correct. So the supply pin is pin 5. I'm going to put this in pin 5. Pin 5. Okay, now this device is specified for a typical of 13 milliamps at 5 volts. I'm going to increase my current because I'm trying to look at the current at 5, and essentially, one of the things you'll see a lot of times on these pins is a diode in the negative direction. If I blow this out here, you can see it's 0.2, 0.4, 0.6. There's your 0.7 diode. Now, what I'm going to do is I'm going to set this to 1 volt per division, and I want to measure the current at 5 volts. So I'm not going to put it in a corner. You can do that, but 1 volt, 2 volts, 3 volts, 4 volts, 5 volts. So this device is drawing, 2, 4, 5 milliamps, which that's under a typical of 13. That's good. And so basically now we're ready to kind of begin pin core testing. What we'll do there is you remove your collector, and we'll short VCC to ground. And you can do this on, you can not short VCC to ground and do a run, without it, and then move it over to VCC and do another run. We're going to kill 2 birds with 1 stone and just go 1 loop around. So essentially now, if you look at the pin out of the devices, I like to set this up to plus or minus 5 volts like this. It's somewhat of a low current of probably like 1 milliamp there. That might require a little bit of adjusting. And we kind of basically group these pins, into their groups. The first pin we looked at was pin 40, and we get in here. And we determined this because it was called the Schmidt trigger. We called this the pin Schmidt trigger. So if you look at pin 40 is deemed a Schmidt trigger input, pin 39 is considered a Schmidt trigger input. Now this is a very common structure you'll see everywhere. We call this a digital input structure, even though on this device it's actually the structure of a digital output or the digital analog converter output. So, following the data sheet, it's 40 is Schmidt trigger, 39 is Schmidt trigger, then 37 through 34 is going to be the same as a digital input. Digital, 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 digital. Now I do believe we'll jump to Schmidt triggers again. And now the whole rest of the side of this chip is actually going to be the same. But it's up to you to take the data sheet, lump the pins that are, in groups at first, based on their definition and their function, and go through and physically look at each chip pin. Then once you determine what pin, how many different structures you have, then you group your structures into groups. So first we went through and we said, all of our DA converter outputs, and we figured out what their structure should look like, and then we figured out what all of the I/O port structures should look like. Then when we saw, hey, both of those are Schmidt triggers, then we lumped them into the Schmidt trigger group. So
and the importance of the devices is to make sure that all the Schmidt trigger curves look the same between all the pins, right?
So we're looking for non-variance. So I'm gonna kind of simulate a failure. When we run down all of these legs along this chip here, we're looking for that structure. If we see it go out here or go here, then that's going to be, this is actually going, hey, I'm shorted, and this is like, hey, I have a higher breakdown, or I might even be open. That's what an open looks like. This is what a short looks like.
You don't want any of them.
Yeah, so you want no variation, in these pins, because you might go to another part, and all of a sudden this curve will be in here, and what that'll means is that either that transistor damaged or it's a different type of process, and so you're kind of you have to use your use your head and determine that, start with a device and use that as a foundation and go from there, and so essentially with this device we kind of ran through it already and knew that every single structure down this whole side, with the exception of the digital inputs over here, are going to look the same. So this is the swipe method. Just go all the way down them like this. So now we're going to go to the to the front side, which essentially only had 2 digital inputs in the front, or actually 4 digital inputs in the front. Then your supplies, and then we see the Schmidt trigger structure all the way down the other side. So this is a good technique to do on large amounts of device pins. It's nice sometimes when you have multiple grounds and multiple supplies to also check that they be shorted together.